All right, let's dive in. Today, we're pulling back the curtain on a really fundamental JavaScript method, object create. Now, this thing is a powerhouse for controlling exactly how objects inherit from one another. And trust me, by the end of this, you'll get the engine that really drives a huge part of the language. So let's get to it.
So let's just start with a question. In JavaScript, how do you make a new object, but have total control over what it inherits, what its parent or its prototype is? Well, that exact problem is why object create even exists in the first place.
So what even is object.create? The best way to think about it is as the blueprint method. See, instead of just building an object out of thin air, it lets you manufacture a brand new one based on a design that already exists. It gives you this incredible, precise control right from the get-go. Okay, let's get the official word straight from the source, the Mozilla Developer Network. It says object.create, well, it creates a new object using an existing object as its prototype. The two most important words there, new and existing. It's all about creating that link between them. To really wrap your head around this, just picture a blueprint for a house. The blueprint itself, it isn't a house, right? But it defines the entire structure. Object.create is kind of like the construction crew. You hand them the blueprint, and they build you a brand new house. Now, this new house is empty, but it's forever linked to that original design. If the blueprint says all doors are blue, then every single house they build from it will have blue doors, unless, of course, you decide to go in and paint one of them red later.
Okay, so that's the theory. But theory is one thing, right? Let's see what this actually looks like in practice. We're going to walk through a really simple, hands-on example to see this whole blueprint idea in action.
All right, let's break this down. First, in step 1, we make our blueprint object, which we'll call person. It's got a property, is human, and a method, print introduction. Then, in step 2, we use our new tool, object.create, to build a new object called me from that person blueprint. Now, right at this moment, me is basically an empty shell, but it has this invisible link back to person. Step 3 is where we customize it. We give me its own properties, like a name, and we even overwrite that is human property. And then, the final step, step 4, we call the print introduction method on our me object. But wait a second, me doesn't have that method, so how does this even work?
And this is where the magic happens. When that print introduction method runs, the special keyword this inside of it points to our me object, not the original person blueprint. And that's why it uses the name Matt from our me object. You see, it inherits the behavior from its prototype, but it uses its own unique state. And that, my friends, is the prototype chain in action.
Now hold on, because object.create has another trick up its sleeve. It has a second optional argument that gives you this almost surgical level of control over your new object's properties. And this is where things get really, really interesting.
Just look at the difference here. On the left, that's a simple object literal. It's how we create objects, 99% of the time. It's clean, it's easy, but on the right, we're using that second argument of object.create. It looks way more complicated, right? So you might be asking, why on earth would I ever do this? Because with this method, you're not just setting a value, you are defining the rules for how that property can behave. So this second argument, it lets you set what are called property descriptors. These are basically rules that control if a property can be changed, that's writable, or if it can be deleted, that's configurable, or if it shows up when you loop over the object, that's enumerable. And here is the big gotcha, the thing you have to remember. By default, they are all set to false. That means if you define a property this way, it's locked down tight. You can't change it or delete it later unless you explicitly go in and set those descriptors to true.
Okay, so let's see how this all ties together in a more, let's say, traditional programming pattern. For a long, long time, object.create was the way you'd mimic what's called classical inheritance in JavaScript. Here's a classic example. Imagine we have a generic shape object, our superclass, and then a more specific rectangle subclass. What we want is for any rectangle we create to automatically have all the powers of a shape, like its move method. And the key is this one line right here. Using object.create, we're telling JavaScript, hey, make the rectangle's prototype a brand new object that is built from the shape's prototype. That one line forges the link between them.
So what we've actually built is a chain. When you create a new rect instance and you try to call rect.move, JavaScript first looks for a move method right on the rect object itself. Nope, not there.
So it goes one step up the chain to rectangle.prototype. Still not there. Finally, it goes one more level up to shape.prototype, and boom, it finds the move method and runs it.
So, we've seen how Object Create can build these really powerful inheritance chains, but this brings up a really important question. In the world of modern JavaScript, is this still the way we're supposed to do things?
And, well, the modern guidance on this is pretty darn clear. The documentation itself says that the class syntax, which was introduced way back in ES 2015, should be your first choice for this kind of work.
So, why the change? Well, the thing is, the class keyword doesn't actually bring a new inheritance system into JavaScript. It's what we call syntactic sugar. It's just a prettier syntax. Under the hood, it's still using the exact same prototypical inheritance we've been talking about this whole time. The class syntax is just a cleaner, more intuitive, and way less error-prone way to get the same result. It does a lot of the heavy lifting for you. But knowing what's actually happening underneath, well, that's what separates a good developer from a great one.
So here's the takeaway. Even if you use the class keyword every single day, understanding object.create means you understand the engine that's making it all possible. You understand the blueprint. And that leaves us with one final thought. Now that you understand the blueprint, what could you build with it?